Hi, I'm Sean Powers, and I want to help you learn everything, do what you love, and most importantly, be kind. Now, today we are starting our Linux Plus series where we're going to learn all the objectives to take the Linux Plus exam to get certified with CompTIA Linux Plus, or if you just want to learn about Linux, great place to be as well. Now, this very first section is basically a summary of the Linux fundamentals. And if you are already a Linux user, great. If not, if Linux is a little intimidating, you can check out, I'll put a link up here to my Linux Essentials course. It's a full course that you can take just to gain a familiarity with Linux before you dive into Linux Plus full on. But anyway, it's not too bad. And we're starting with section 1.1.1. I'm just going to cover this section today, and this is basically just a look at the FHS, or the Filesystem Hierarchy Standard, which just means that Linux systems all use the basic same locations for different types of files. Now, you'll notice this is just a list of directories, and I could just like explain this and you could take notes, but that's kind of boring. So let's actually look at the command line for how files and directories work. And then I'll take these by section, not just to tell you what they do, but kind of like why they do what they do so that they can stick in your brain a little bit easier than just rote memorization. Now, the reason it's so important for there to be a standard for how files are stored on a Linux system is because in Linux, everything is a file. And I do mean everything. Like, of course, files are files, but a hard drive on your system is represented as a file in the dev folder. If you insert a USB drive, that drive is represented as a file on your system. It's mounted on a folder on your system. So every single thing is a file. Like I said, a file is a file. Hardware is referenced as a file. Now, I should take a second because I will probably get comments if I don't address this. Directories are the actual proper name for, on a file system, like a container of other files or other directories. Directory is the absolutely correct term. But folders is often used synonymously because it's a good metaphor for what a directory actually is. Again, it's not a perfect metaphor, but I will say folders or directories, and when I do that, I'm going to use them synonymously, meaning the exact same thing. If you don't like it when people say folders, I apologize. It's just the way that I often explain it. And so directories and folders, when I say them during this whole series, they're going to mean directories on the Linux system. So yes, files are files, hardware is files. Network shares are mounted on directories, so you don't actually have like a C drive or an A drive. You just have a folder or a directory location, and that's where the remote file system lives. Even kernel configurations are stored as files on the running system. We're going to look at that in just a second, but like kernel configuration stored in a file. It's a virtual file. There's a little more complexity there, but it's still represented as a file. So everything is a file, and that's why it's important to have standards on a Linux system. So when somebody creates software for Linux and they install it, the different files, which represent either files or hardware, etc., live in the same place regardless of the distribution that the person is actually installing the application on. Now, there's a couple cool little things here. I'm in the documents folder, and I'm going to type ls, and you'll see these are directories. In fact, let me say ls minus l. These are directories, and inside of these directories are some files. So I can say ls minus l to show a listing inside the home folder, and we'll see, oh, there's another folder inside there. And if I look inside that folder, there are a couple files in there, okay? Directories or folders exist, files or folders can exist inside of there, and it just makes this hierarchy. Wherever you are in the system, it's a whole file system based on directories and files that can be nested within a bunch of different directories and that sort of thing. This is probably perfectly clear. If you're watching this video, this probably isn't new information, but I do want to show you. If we do ls minus l, it'll show a listing, and then a will show all. And we're going to have a couple other directories that are shown here, but they're strange. These are actually relative, as opposed to like these are actual directories named home, secret treehouse notes, work. These, the one called dot dot and the one called dot, are dynamically created, or relative, I guess is a better term. They're relative to whatever folder you're in, because dot, the single folder or single directory named dot, means the current directory. So whatever directory we're in fact, right now on this system, we're on in the documents folder inside of our home directory. Documents is the dot folder because that's where we are currently located on our system. Dot dot means the parent directory, or the one above it. Okay, so if I were to say cd for change directory to dot dot, we're going to go up a directory or to the parent directory, which is just my home folder. And now if we do ls, we'll see documents is in this folder because we change directory to the parent directory of documents, which is just the spowers folder, and there is documents. Now, if you want to see it laid out, there's a cool program. This is just bonus material, right? This isn't, you're not going to see this in the Linux Plus exam. But if you go to, let's go back into our documents folder because I set up some things in there. And if you type the command tree, just like, tree growing outside, it will show you all the files and directories in a nice little chart thing. So you can visually see what it looks like. So like we have the home folder or directory, and then inside there is the AP English with a couple text files, secret treehouse notes, looks like there's a video, the oath, the rules. Inside of our work directory, there are two directories, accounting and TPS reports. The expenses.xls is a file inside the accounting directory, and then TPS reports contains January 1980 WordStar document. And then also memo. I don't know if you read the memo on TPS reports. But anyway, that's how directories and files are set up. They just work. I mean, you understand this, but I wanted to show you, and especially that dot and dot dotting. So if we say like cd to dot, what do you think will happen? We stay in the same directory, right? Because dot means current directory. So we change directories to our current directory. Boom, we're still in the same exact directory. All right. Now let's look at some of those standards as far as where the files are always going to be on a freshly installed system. Not inside, not like our own stuff like we did here with our English and work folders and stuff. I mean like the system as a whole, the FHS that this video is about. Let's look at what those things are actually set up to do and maybe why they're set up that way. Now, again, this is just a cut and pasted version of that entire list of things, but I kind of chopped them up into pieces so we can look at them individually. So, for example, we're just going to go through these and talk about them. The home directory, this is like / right off the root directory of our hard drive or of our system. Doesn't have to be a single hard drive. Off of our system, home is where user directories are stored. So it's going to be like home as powers, that would be like my home directory. Now, the root user's home directory is not in that folder. Usually it's just right at the root level, which I know root and root, but the root level is generally what we just call the very top of the file system. And then the word root, ROOT, is where the root user's home directory is. And that's because a lot of times the home directory is on a separate either partition or on a network share or on a separate hard drive. And we want the root user to be able to have access to their files, even if we boot in like recovery mode or single user mode. So root is generally not stored, their home stuff isn't stored inside the home folder like every other user on the system. All right, so that's this section. Let's look at over here. These are just kind of a couple other root level folders or directories. The boot directory, this is where the bootloader and the kernel files live, okay? This can have specific needs that for some reasons, which we'll discuss a little bit later, it might need to be on a very small partition. So the boot directory is often its own partition, not always, sometimes just a folder, but this is a place where the bootloader and the kernel files live. ETC, it's funny, this is a little bit of a controversy, like where did it come from? Everybody I know calls it the etc folder, ETC, or sometimes it's shortened to etc. You'll hear people call it etc, like ET and then C, etc. It's just easy to say. We're pretty sure it just came from like etc, where these are where all of the text configuration files go for installed applications. But some people don't like that and they try to like wedge in an acronym, and I don't even remember the silly acronyms. But what you need to know for the test is that this is where configuration files for programs go. This is where all configs go. Right? If you have an application installed or the system itself, all of the configuration files are going to be in the etc folder. Opt is one that's not used terribly often. This is for add-on packages, like third-party add-ons that have all the stuff they need. A lot of times proprietary software won't use system libraries. They'll just have everything self-contained. So if you have like a third-party application, it'll often go in the opt folder. That's kind of what that folder is used for. I kind of use it for my Docker configuration stuff, which isn't perfect, but it kind of fits the bill, right? I mean, it's an application that is not like standard part of the system. So I usually put, like, if I have a mounted volume, I'll usually have that in the opt folder. I'll usually do opt Docker, and then for every one of my Docker containers, I'll have like a directory inside there, and that's where I store the the persistent information. But that's just my personal preference. That's not part of FHS. FHS just says that opt is where add-on packages go. Media, this is where removable media is mounted. Remember I said like a USB drive, you plunk it in there. Two things are going to be created. A device file, like in the dev folder, which we'll look at in a second, to the actual hard drive itself that you plugged in. But then the contents are going to be mounted in a directory, and that directory is going to be inside the media folder. Now, hold on, I kind of scribbled over my stuff here. The MNT or mount folder, this is where temp mounted file systems go. Like if you need to mount a file system temporarily, you create a directory inside MNT, so mount something, and then that's where you mount it. I have to be honest, the MNT folder is generally where I put things that don't fit elsewhere. Like let's say I have a giant video collection and I want to mount that network share on my local computer. I will usually make something like MNT/videos directory, and I will mount that remote share on there and have it mount on boot. It's technically designed for temporary mounted file systems, but I usually put things in there that I want to keep permanently anyway. Again, these are guidelines, not rules when it comes to the individual user. It's when you develop software and distribute it that you have to make sure you're following the rules more precisely. But that's where I usually put stuff when I mount it. The temp folder is just that. It's temporary files. So a lot of times when a software is running, it will need to temporarily store stuff somewhere. And that temp directory is where those things are stored. Now, this is important to know. At the root level, the /TMP folder is usually deleted. All the stuff in there is usually deleted when you reboot the system. So if it's like not super temporary, it's something that you hope sticks around for a while, like, and persists between reboots, do not put it in the temp folder. There's another place I'll tell you in just a second where you can, but the temp folder is for temporary files, but it's usually deleted on reboot. Let's see. Let's go down over here. I know I'm kind of going out of order, but I just kind of scattered them around the page. SBin, this is where binary files go, but essential is key here. Essential means it has to be available in single user mode. So like recovery, like when the system first boots up, it has to be in that essential class where we can't mount another hard drive. We can't mount any, remote network share. If this is something that is essential for the system to run, it has to be in this SBin folder. And then essential binaries that aren't system specific, like if it doesn't necessarily have to be run as root, but it's essential in a single user mode situation, it's going to be in bin, like bin bash, like the shell interpreter is in that folder because you're going to need that even in a single user mode system. So it's essential, but it's not only run by root, right? Other users can run stuff in the bin folder. And then the lib, these are system libraries, like shared libraries that are needed for essential binary files, right? So this is library files, but only library files for these two things go in there, because the user folder, or USR, which is up here, which we're looking at now, this is things that are not needed for single user mode. This is like after it's booted, we're not in recovery mode, anything like that. It's actually a fully running system. Most things go in this user directory. The user directory, user/bin, this is where most of the files that are going to be on a system are located. User lib, these are libraries, like shared library files for the actual command binaries that are in user bin. User local is a little bit different. User local is specific to the computer you're on. And one that's really common is user local bin. I usually put my custom scripts for a particular computer in user local bin, and that way it's accessible for anybody on the system, but it's not something that is generally shared between systems or installed. Like if you download a package from like a repository, it's not going to put stuff in user local. That's for the local system, right? And that's, like I said, usually where I put like bash scripts that I write go in there. And that's all of these are in the USR directory, and that is not essential. That's like, it's considered secondary. I couldn't think of the word. It's considered secondary because it doesn't have to be available like these down here do in single user mode. So that's why they exist in different places. And on the test, they might ask you like, let's say we have a program that is used for word processing. Where would you expect to find that binary file? And where you would expect to find it is in user bin, because a word processor is not something that would be considered essential for single user mode. So it's going to be in the user bin folder. And that's the kind of question that you'll get on the exam. All right, let's see, what else do we have here? Oh, I'm going to save the virtual file systems for last. So over here, which is kind of sideways and hard to read, but it wouldn't fit any other way, var. So VAR, this is where files that change a lot live. So like log files that are constantly being written to are in var log. Files that will come and go, like mail files, like if it's a mail server like email, they will go in like var mail, spool, or anything that is written to, deleted, moved around a whole lot is going to go in a var inside the var directory. And the reason these are all chopped up like this is a lot of times a hard drive will be partitioned. So like if the var partition fills up, it doesn't crash the entire system. You know, like all of the other stuff, like their boot folder and SBIN and stuff, they aren't going to crash if the var folder or var partition on the hard drive fills up. Or sometimes it'll be a whole separate hard drive that you have for var. So for like something that is a little more robust and isn't going to wear out from constantly being written, right? Hopefully that makes sense. That's why it's split up like that. And I did promise earlier I'd talk about, like, remember up here, this temp folder is usually erased when the system is rebooted. If you have something that is considered a temp file, like you're running a program and it just temporarily stores stuff, but you don't want that stuff to disappear if the system is rebooted, var temp is the directory you want to store those temp files, because it works the same as the temp folder. The difference is this one is generally not erased. Like everything in there isn't going to be erased when the system is rebooted. So it's a little bit safer to store things there that will persist between reboots. And then lastly, I know this is just a lot of rote memorization, but hopefully at least this helps make it stick in your brain a little better. But virtual file systems. Remember I said everything is a file? Well, that includes like hardware is represented as files. So in the dev folder, that stands for device, and that's going to be all the devices on your system, like your sound card, your hard drive, your NVMe drive, your COM ports, like like serial ports, your USB ports. All of those are going to be represented as files inside the dev directory, and they're going to be populated as the kernel recognizes that hardware. It's going to create files that represent those different devices. And then there's a little bit of a story behind the other two, proc and sys. Proc is it's generated on the fly, so it's all virtual, stored in RAM, but they are actual like files in your file system. And what these are, these represent process information. Thus the word proc, it stands for process. So every running process on your system will store its like in-state memory configuration in folders inside here, okay? However, they also started putting other stuff in there. So the process folder was very convenient for processes to store their running information. Well, they thought, hey, you know what? It'd be nice to have some kernel information stored in there too, and some driver information and networking information. And they just started dumping all sorts of live configuration information in the proc folder. And after a while, you know what, this is getting kind of messy. The proc folder was designed for processes, so why don't we create a different virtual file system called sys, and that's where we will put things specifically about like device configurations, driver configurations, kernel configurations. And that was great in concept. The problem was a lot of the stuff was already in proc. People knew it was there. Moving it would just be unnecessary work. So what we end up with is kind of a messy proc file system and a slightly underused sys file system. Well, let's look at it really quick just to show you what I'm talking about. All right, so here we are. Let's go into just proc. It's just, like I said, it's just a directory. And if we do an ls, we're going to see a couple things. One, all of these numbers represent process IDs. All of these are different processes that are running on the system. And inside each one of these, so like ls 1872 there on the bottom, inside there, these are files and some more directories, but all of this is running information. These are all stored in the RAM on our system, generated on the fly as the process starts up. This is just where it stores its information in a place that can be accessed by other programs or by itself. And all of these are just settings, memory settings, but they're all represented as files. Again, everything in Linux is a file. And you can see that that is great. All these process numbers are here. But there's also a bunch of other stuff over here that, like I said, kernel stuff was starting to get put in there, network stuff was starting to get put in there. And so they said, you know what, it's getting too cluttered, so we're going to make the sys directory. And if we go into the sys directory, we'll see this is much neater, isn't it? Very neat, very organized. There's the kernel, there's power, hypervisor information, file system information, devices, firmware, all of these. And let's look inside firmware. Again, even these are very, very organized. The only problem is it's not terribly utilized, or it's underutilized as a whole because people have been using the proc file system. So this is where technically kernel information, driver information, firmware information that is generated in real time when the system boots up, this is where that configuration information should be stored, but a lot of it is still over in the proc file system too. So it's kind of a half and half transitional type thing. Will it ever be neat and tidy in the proc file system? I have my doubts. It works, and you know, people don't normally go in there, so it is what it is. But that's what those two things are doing. The proc and the sys are both virtual file systems that show you and like on the fly generated files that represent the currently running system. Now, I know that that was a whole bunch of like information about why stuff is where, but what I encourage you to do is, one, I'll put a link to the Wikipedia page that has like the actual full-blown explanation for all of the FHS standard directories and what they are for and why they're for that, etc., etc. So look at that, but then go into your system, whatever system you're using, your VM, and look inside of those directories and see if it makes sense, like why this is here, what sort of files or what binaries are going to be in sbin, in sbin versus user bin. See if you can see why things are considered essential, why things are considered system essential, why things are considered not essential but secondary, that sort of a thing. And hopefully you'll get a better grasp for why things are where they are on the Linux system. And with that, you go play, and I'll get ready for our next video, and that's where I'll see you. See you next time.